Every day, billions of people reheat leftover meals, assuming that once food is heated until it is hot, it is automatically safe to eat. While reheating is a common and practical habit, modern research shows that the issue is more complex than simply reaching the right temperature. In some situations, the way food is stored, reheated, and consumed can influence the formation of compounds that may affect long-term health. There is one statistic I would like you to remember throughout this discussion. Approximately 1 in 6 cancer cases worldwide has been linked to dietary and lifestyle factors. Diet is one of the most important modifiable risk factors for chronic disease, second only to tobacco use in many global analyses. This does not mean that reheated food alone causes cancer, but it does highlight why understanding safe food handling and preparation is so important. One aspect that receives surprisingly little public attention is what happens to certain foods at the molecular level after they have already been cooked, stored, and then heated again. These chemical changes occur silently. You cannot see them, smell them, or taste them, yet they may alter the nutritional quality of food, and in some cases, increase exposure to compounds that researchers continue to investigate for their potential health effects. My name is Dr. William, and for more than 15 years, I have studied nutritional biochemistry, food science, and preventive medicine. Throughout my career, my work has focused on understanding how cooking methods, food storage, and heat exposure influence the chemical structure of foods and how those changes may affect human health. In today's discussion, I want to examine 4 foods that many of us regularly prepare in advance and reheat later. These are foods that are probably sitting in your refrigerator right now. Scientific studies have shown that under certain conditions, reheating these foods can trigger measurable chemical changes. Understanding these changes can help you make more informed decisions about food preparation and storage. I encourage you to stay with me until the end because the 4th food on today's list often surprises even people who are highly health conscious. It is commonly viewed as one of the healthiest foods available, yet very few people are aware of how repeated heating may influence its chemical composition. Before we continue, I want to make an important point. This discussion is not intended to create fear about eating leftovers or to suggest that every reheated meal is dangerous. Instead, it is about understanding how repeated exposure to certain compounds over months and years may contribute to chronic disease risk. Cancer rarely develops because of a single meal or a single habit. Rather, it is usually the result of many biological processes occurring gradually over time, influenced by genetics, lifestyle, and environmental factors. Among the compounds scientists study most closely are free radicals, advanced glycation end products, often called AGEs, nitrosamines, and products of lipid oxidation. Depending on the food and the way it is prepared, these compounds can form during cooking or repeated heating. Ongoing research continues to explore how prolonged exposure may contribute to inflammation, oxidative stress, and cellular damage, all of which are recognized as important factors in the development of chronic diseases, including cancer. Several compounds produced during high-temperature cooking or food processing have been evaluated by international organizations such as the World Health Organization and the International Agency for Research on Cancer. Some have been classified as known or probable carcinogens based on the available scientific evidence. While the level of risk depends on many factors, including the type of food, cooking temperature, frequency of exposure, and overall dietary pattern, these findings remind us that everyday cooking practices deserve careful attention. Perhaps the most important message is that the people who may benefit most from this information are not individuals with unusual eating habits. They are ordinary families preparing balanced meals, storing leftovers responsibly, and trying to make healthier choices. Foods such as rice, lean poultry, leafy vegetables, and eggs are all nutritious foods, but understanding the safest way to prepare and reheat them can further reduce potential risks. Before we examine each food individually, let me briefly explain why I feel qualified to discuss this topic. In an age where health information spreads rapidly online, it is important to know whether advice is supported by credible scientific evidence. My medical training focused on internal medicine, followed by advanced study in nutritional biochemistry. Over the past decade and a half, I have reviewed hundreds of peer-reviewed studies examining how cooking methods, food storage, and repeated heating influence proteins, fats, carbohydrates, and the chemical byproducts they produce. For this presentation, I have carefully reviewed research published in respected scientific journals, including Food Chemistry, the Journal of Agricultural and Food Chemistry, Carcinogenesis, and the Lancet Oncology. Throughout this video, I will explain these concepts using clear, practical language so that you can understand not only what researchers have discovered, but also what those findings may mean in your everyday life. My goal is not to sell supplements or promote unnecessary fear. My goal is to translate complex scientific research into practical advice that can help you and your family make informed choices. Preventive medicine begins with education, and even small improvements in food handling habits can contribute to better long-term health. Before we discuss the individual foods, it is important to understand a few basic principles of food chemistry because they provide the foundation for everything that follows. When food is cooked for the first time, heat causes predictable changes. Proteins unfold, starches absorb water and gelatinize, and fats melt and redistribute. These are normal processes that make food more digestible and enjoyable. However, once cooked food has been stored, especially for several hours or days, and is then heated again, additional chemical reactions may occur. The first process is oxidation. During storage, oxygen gradually reacts with fats and proteins, making them less stable. When these molecules are reheated, oxidation can accelerate, producing compounds such as lipid peroxides and melandialdehyde. Laboratory research has shown that these substances are capable of damaging cells and DNA under certain conditions. The second process involves the Maillard reaction. This reaction gives cooked foods their appealing aroma, flavor, and golden brown color. But when foods rich in proteins and carbohydrates are repeatedly exposed to high temperatures, greater amounts of advanced glycation end products, or AGEs, may form. Elevated levels of AGEs have been associated with chronic inflammation and oxidative stress, both of which are linked to many long-term diseases. The third mechanism involves nitrate conversion. Certain vegetables naturally contain nitrates that are generally considered beneficial. However, after cooking and storage, bacteria can convert some of these nitrates into nitrites. During reheating, additional reactions may occur that can contribute to the formation of nitrosamines, compounds that have been extensively studied because of their potential carcinogenic properties. As we continue, remember these three key mechanisms: oxidation, advanced glycation, and nitrosamine formation. They will help explain why different foods respond differently when reheated. Let's begin with the first food on our list: cooked rice. Rice is one of the most widely consumed staple foods in the world and serves as a primary source of nutrition for billions of people. It is also one of the foods most commonly prepared in large batches and reheated later. Interestingly, the greatest concern is not always the reheating itself. Instead, much of the risk depends on what happens while cooked rice is cooling and being stored. Cooked rice can provide favorable conditions for the growth of a naturally occurring bacterium called Bacillus cereus. This bacterium is commonly present in raw rice and may survive the initial cooking process because of its heat-resistant spores. If cooked rice is left at room temperature for too long before refrigeration, these spores can multiply and produce toxins. Although reheating may destroy many bacteria, it does not reliably eliminate toxins that have already formed. These toxins are heat-stable and may remain active even after microwave or stovetop reheating, increasing the risk of foodborne illness. Another area of scientific interest involves the effects of certain bacterial toxins on cellular function. Experimental studies have shown that cerulide, one toxin produced by Bacillus cereus, can interfere with normal mitochondrial activity inside cells. Because healthy mitochondrial function is essential for energy production and cellular regulation, researchers continue to investigate whether chronic exposure to these toxins may contribute to broader health effects. More research is still needed to fully understand any relationship with cancer risk. researchers have also examined another compound associated with repeatedly heating starch-rich foods under high temperatures, acrylamide. Acrylamide forms when natural sugars react with the amino acid asparagine during intense heating. The International Agency for Research on Cancer classifies acrylamide as a Group 2A carcinogen, meaning it is considered probably carcinogenic to humans based on the available evidence. The good news is that practical steps can significantly reduce these risks. Whenever possible, prepare only the amount of rice you expect to eat. If you have leftovers, cool the rice quickly. Refrigerate it within 1 hour, store it in shallow containers, consume it within 24 hours whenever practical, and avoid reheating it more than once. These simple habits help reduce bacterial growth while minimizing repeated heat exposure. In the next section, we will examine another food found in millions of refrigerators around the world, cooked chicken, and why repeated high-temperature reheating can change the chemistry of one of our most popular sources of lean protein. Now let's turn our attention to the second food on our list, cooked chicken. Chicken is one of the most commonly consumed sources of lean protein worldwide. It is recommended by physicians, registered dietitians, athletes, and individuals striving to maintain a balanced diet. Because it is often prepared in large batches for meal planning, reheating cooked chicken has become a routine part of many people's daily lives. While chicken remains an excellent source of high-quality protein, it is important to understand how repeated exposure to high temperatures can alter its chemical composition. When cooked chicken is reheated, especially at high temperatures or for prolonged periods, the proteins and fats within the meat undergo additional oxidation. Oxidation is a natural chemical process, but repeated heating can accelerate it, producing compounds that scientists continue to investigate for their potential effects on long-term health. One group of compounds that has received considerable scientific attention is known as heterocyclic amines, or HCAs. These substances are primarily formed when muscle meats, such as chicken, beef, and pork, are cooked at high temperatures, including grilling, frying, broiling, or repeated reheating. HCAs have been extensively studied because laboratory research has shown that after they are metabolized by the liver, some can interact with DNA inside cells. Damage to DNA is one of the biological events associated with the development of cancer. Although cancer risk depends on many factors, including genetics, overall dietary habits, and lifestyle, reducing unnecessary exposure to these compounds is considered a sensible preventive strategy. Large population studies have also explored this relationship. Some research has found that people who regularly consume heavily browned or repeatedly heated poultry may have a higher risk of certain cancers, including colorectal cancer. Other observational studies have suggested possible associations with pancreatic cancer, although these findings should be interpreted carefully because many additional lifestyle factors may contribute to overall risk. Another important consideration involves lipid oxidation. Even though chicken is relatively lean, it still contains fats that become increasingly susceptible to oxidation after cooking. During repeated heating, oxidation byproducts such as malondialdehyde and related aldehydes may accumulate. These compounds have been associated with oxidative stress and inflammation in experimental studies. Fortunately, minimizing these changes does not require major lifestyle adjustments. Whenever practical, prepare only the amount of chicken you expect to consume. If leftovers are unavoidable, cool them promptly, refrigerate them without delay, and consume them within recommended food safety timeframes. If reheating is necessary, use moderate temperatures rather than excessive heat, and avoid repeatedly reheating the same portion. In many situations, cold-cooked chicken used in salads, sandwiches, or wraps can be an excellent alternative that avoids additional heat exposure while still providing a nutritious source of protein. Now let us examine the third food on today's list, a food that many people consider one of the healthiest choices they can make. Spinach, along with other leafy vegetables such as Swiss chard, beet greens, celery, and certain varieties of lettuce, is naturally rich in vitamins, minerals, antioxidants, and dietary nitrates. These nutrients contribute to cardiovascular health, healthy blood pressure regulation, and overall well-being. There is no question that these vegetables deserve an important place in a balanced diet. However, the way they are stored and reheated deserves careful attention. Naturally occurring nitrates found in fresh vegetables are generally considered beneficial. The concern begins only after the vegetables have been cooked and stored. During refrigeration, naturally occurring bacteria can gradually convert some nitrates into nitrites. This conversion is a normal microbiological process and can occur in several nitrate-rich vegetables. If those vegetables are later reheated, additional chemical reactions may occur. Under certain conditions, nitrites may react with amino compounds to form substances known as nitrosamines. Nitrosamines have been studied extensively for many decades. Several members of this chemical family have demonstrated carcinogenic properties in laboratory and animal research, and some are classified by international health agencies as probable or known carcinogens under specific exposure conditions. It is important to emphasize that eating spinach itself is not harmful. In fact, spinach remains one of the most nutritious vegetables available. The issue involves repeated cooking, prolonged storage, and reheating, not the vegetable itself. Food safety authorities have issued guidance encouraging proper storage of cooked leafy vegetables and minimizing unnecessary reheating after extended refrigeration. From a practical standpoint, the safest approach is relatively simple. Whenever possible, prepare only the quantity you intend to eat. Freshly cooked spinach provides excellent nutritional value with minimal concern regarding these chemical changes. If leftovers remain, cool them promptly, store them in an airtight container, and consume them within a short period. Many nutrition professionals recommend eating leftover cooked spinach cold rather than reheating it, particularly if it has been refrigerated for an extended time. This approach helps preserve nutritional quality while reducing the likelihood of additional chemical reactions occurring during repeated heating. So far, we have discussed three very different foods, yet they share an important lesson. Rice, chicken, and leafy green vegetables each undergo distinct chemical changes during storage and reheating. Understanding these differences allows us to make simple adjustments that may reduce unnecessary exposure to potentially harmful compounds without eliminating these nutritious foods from our diets. In the next section, we will examine the fourth and perhaps most surprising food on today's list: eggs. Although eggs are among the most nutrient-dense foods available, there are several important considerations regarding how they should be reheated and why this topic deserves greater public awareness. Now we come to the fourth and final food on today's list: eggs. For many people, this may be the most surprising example. Eggs are among the most nutrient-dense foods available. They provide high-quality protein containing all 9 essential amino acids, along with important nutrients such as choline, selenium, vitamin B12, lutein, and zeaxanthin. These nutrients support brain function, eye health, immune function, and many other aspects of overall health. There is no question that eggs can be an excellent part of a balanced diet. However, the way they are stored and reheated deserves careful consideration. When eggs are cooked for the first time, the fats and cholesterol naturally present in the yolk undergo normal chemical changes that occur during heating. If those cooked eggs are later refrigerated and then reheated at high temperatures, additional oxidation reactions may take place. Researchers have identified several oxidation products that can increase during repeated heating, including compounds known as oxysterols. Oxysterols are oxidized forms of cholesterol that have attracted significant scientific interest because laboratory and animal studies suggest they may contribute to inflammation, oxidative stress, and cellular injury. Some experimental research has also shown that certain oxysterols can interact with DNA and influence normal cellular function. Although scientists continue to investigate exactly how these compounds affect human health over the long term, limiting unnecessary exposure is considered a reasonable preventive approach. Repeated heating may also further denature egg proteins. While denaturation itself is a normal part of cooking, excessive reheating can make proteins more difficult to digest and may reduce the availability of certain nutrients. Some researchers have suggested that repeated heating of sulfur-containing amino acids naturally found in eggs, may increase the production of oxidation products that contribute to oxidative stress within the digestive tract. Although more human research is still needed to fully understand these mechanisms, maintaining healthy cooking practices remains one of the simplest ways to reduce unnecessary exposure to these compounds. The practical recommendations are straightforward. Whenever possible, enjoy eggs soon after they are prepared. If you cook hard-boiled eggs in advance, store them in their shells under refrigeration and consume them cold when practical. If reheating is necessary, use gentle, even heat rather than high microwave settings or prolonged cooking times. Avoid reheating egg dishes repeatedly and never heat the same leftovers multiple times. As I reviewed the scientific literature on food reheating, oxidation, nitrosamine formation, and protein chemistry, my primary reaction was not alarm. It was concern that this information is not discussed more often in everyday health education. These findings are not hidden away in obscure publications. They appear in peer-reviewed scientific journals and are discussed by food scientists, toxicologists, and public health researchers around the world. Yet many families have never been taught how simple storage and reheating practices can influence the chemistry of everyday foods. Every day, millions of people prepare meals with the best of intentions. Parents pack lunches for their children. Older adults prepare leftovers because it is practical and economical. Busy professionals rely on meal preparation to save time during the week. Athletes and fitness enthusiasts prepare chicken, rice, eggs, and vegetables in advance because they believe they are making healthy choices. These are sensible habits. The goal is not to discourage meal preparation or leftovers. Instead, the goal is to make those habits even safer by applying what modern nutritional science has taught us. Let's briefly summarize the 4 foods we have discussed. First, cooked rice. The primary concern involves the growth of Bacillus cereus if rice is cooled or stored improperly. This bacterium can produce heat-stable toxins that reheating does not reliably destroy. Repeated high-temperature heating of starch-rich foods may also increase the formation of acrylamide under certain conditions. Second, cooked chicken. Repeated exposure to high temperatures can increase protein and lipid oxidation and promote the formation of heterocyclic amines, compounds that have been widely investigated for their potential role in cancer development. Third, spinach and other nitrate-rich leafy vegetables. After cooking and refrigeration, bacterial activity may convert naturally occurring nitrates into nitrites. During reheating, these compounds may participate in reactions that can form nitrosamines under certain conditions. Fourth, eggs. Repeated heating may increase cholesterol oxidation products such as oxysterols and accelerate lipid oxidation, while excessive reheating may also reduce nutritional quality. Although the mechanisms differ, they all reinforce the same principle. How we store, handle, and reheat food can influence its chemical composition. The encouraging news is that reducing these risks does not require expensive products or complicated diets. Small changes in everyday habits can make a meaningful difference. Whenever possible, prepare portions that match your immediate needs to reduce the amount of food requiring reheating. Cool cooked foods promptly rather than leaving them at room temperature for extended periods. Store leftovers in shallow, airtight containers so they cool efficiently and remain refrigerated at safe temperatures. Consume refrigerated leftovers within recommended food safety guidelines and avoid reheating the same food more than once whenever possible. Use gentle reheating methods instead of exposing foods to unnecessarily high temperatures for prolonged periods. A food thermometer can also be a valuable tool, helping ensure foods are reheated safely without excessive overheating. Most importantly, remember that overall dietary patterns matter far more than any single meal. A balanced diet rich in fruits, vegetables, whole grains, legumes, healthy fats, and appropriately prepared proteins remains one of the strongest foundations for long-term health. Before we conclude, I would like to hear from you. Which of today's 4 foods surprised you the most? Was it rice, chicken, spinach, or eggs? Your experiences and questions often inspire future educational topics, and understanding what interests you helps ensure these discussions remain practical and relevant. If there is another food you would like me to examine in a future presentation, please let me know. Continuing to explore nutrition through evidence-based science is one of the best ways we can all make informed decisions about our health. Finally, I would like to leave you with one important message. Knowledge should empower us, not frighten us. The purpose of learning about food chemistry is not to make everyday meals feel unsafe. Rather, it is to understand how small, practical choices can support better health over time. If you believe this information could benefit a family member, friend, or colleague who frequently prepares meals in advance, consider sharing it with them. Helping others make informed decisions is one of the simplest ways we can contribute to better public health. As always, I would like to emphasize that this presentation is intended for educational purposes only. It is not a substitute for personalized medical advice, diagnosis, or treatment. Scientific knowledge continues to evolve, and recommendations may change as new high-quality evidence becomes available. If you have specific dietary concerns, underlying medical conditions, or questions about your individual health, please consult your physician or a registered dietitian. Personalized guidance will always be more appropriate than general information presented in a video. Thank you for joining me today. I hope this discussion has helped you better understand the science behind food storage and reheating, and I look forward to sharing more evidence-based health information with you in our next video.